Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidity of substituted phenols depends on the ability of substituents to stabilize or destabilize the phenoxide anion formed after deprotonation. Electron-withdrawing groups, EWGs, stabilize the negative charge on the phenoxide and increase acidity. Electron-donating groups, EDGs, destabilize it and decrease acidity. Moving on to the next step. Methyl groups are electron-donating via hyperconjugation and induction. 3 methyl groups, at ortho and para positions, increase electron density on the ring and on oxygen, destabilizing the phenoxide anion. This makes compound to the weakest acid among the 3. Moving on to the next step. Chlorine is weakly electron withdrawing by induction, I effect, but also has A plus M, resonance donation, effect. The net effect of 3 Cl substituents is moderate electron withdrawal, moderately stabilizing the phenoxide. This makes compound 1 more acidic than compound 2 but less acidic than compound 3. And for the final step. Nitro groups are strongly electron withdrawing by both induction and resonance, I and M. 3 nitro groups at ortho and para positions very effectively delocalize and stabilize the negative charge on the phenoxide through resonance. This makes compound 3, picric acid, the strongest acid of the 3. It is a well-known strong acid among phenols, pKa 0.38. Compound 2, weakest, compound 1, compound 3, strongest, i.e. 2,1,3. A. 2,3,1, wrong, places trichlorophenol as most acidic, but trinitrophenol is far more acidic. B. 3,1,2, wrong, reverses the order entirely, trinitrophenol is the strongest acid, not weakest. C. 1,2,3, wrong, places trimethylphenol as more acidic than trichlorophenol, but methyl groups are electron-donating and should decrease acidity. Therefore, the correct answer is D. Therefore, the correct answer is option D.